A body accelerated by rotates, as explained, also around the axis of the running direction. This driving acceleration, A, drives every point in the body in a tangential direction. That means that every point has the same tangential force. So every mass point in the body has an identical tangential force. The rotational force of the whole body is equal to the sum of all individually. That means that the rotational force of a rotated body is equal to the primal force that drives the body in the direction of travel. With this force, a body opposes the force that prevents the body from rotating. And so that a body can rotate in another's gravitational field, it needs a rotational force, the strength of which must be greater than 2/pi of this field, c. The power of the gravitational field, Real Physics, number 9. In the concrete case, it is said that so that the Earth can rotate in the Sun's gravitational field, it needs a rotational force that must be greater than 2/pi of the Sun's gravity field of approximate 0.0059. Normally a rigid body of revolution rotating with angular velocity omega has the inertial torque. And the angular velocity of the point mass in the body is the same everywhere. But with the grarotated body it is different, because the body is not driven on the outer edge by the gravitation, but rather from the inside. Therefore, its inertial torque is not the same either. For a grarotated body, all point masses are accelerated with the same acceleration in the tangential direction. And the resulting inertia torque of each point mass is also different due to their different radius. Because the inertial torque of all point masses with the same radius is equally strong, we can split a sphere into many interconnected cylinder jackets in order to calculate the inertial torque of the body. The mass of a single jacket is determined as follows. The inertial torque of a homogeneous ball around its axis is the sum of all jackets. So the inertial torque of a homogeneous sphere is the same. The physical meaning is that the speed of rotation of a homogeneous spherical body grarotated by an acceleration, a, is limited to a maximum. So also the speed of rotation of a grarotated body is slowed down by the rotational inertia and thereby limited. This is an average of all point masses in the body. Therefore, the rotational energy is also limited to a maximum of. Then the same question arises again, where did the rotational energy go, which could actually have increased infinitely if the rotational speed were not limited? And the total rotational energy after the maximum rotational speed, which is assumed to be v, is like the kinetic energy. The entire rotational energy after the maximum rotational speed has been divided into three parts. The first part is the rotational energy, which remains unchanged. The second part is the work that was used against the rotational inertia. The third part is also the energy that is left over and will continue to rise and for which there is no application. This energy corresponds to the work that the acceleration can do after the maximum rotation speed. So where should this be consumed? Now all degrees of freedom of movement are restricted. Even if there was one, the third partial energy would have remained after the same process. This energy increases with the square of time. It could be dangerous if not consumed. So, ironically, we have the problem with too much energy and we don't know where it went while others are desperately looking for extra energy. One possible way to solve this problem would be to use a disc brake-like mechanism used in the automotive and mechanical engineering industries. However, only a highly intelligent person is able to build such mechanisms. Or could it be possible that such a mechanism is also used in nature? As already mentioned, the rotated angular velocities of all cylinder jackets are different. For everyone this is the same as follows. That is, the smaller the jacket, the faster it rotates. This creates frictional resistance inside the body between adjacent jackets, which slows down the rotation of the body. Assuming that the driving, A, is exhausted before the maximum rotation speed is reached, then the driving force has finally been stopped. An ingenious braking system from nature. And the energy that is consumed by working against frictional resistance is converted into heat. Thank you very much for your attention. See you next time.